Okay, so this is a double and compound angle formula. Uh, In the question, they've asked us to express cos 4x as just cos, essentially coefficient of 1 in front of the x. That's the idea here. So we don't want to have any double or triple or quadruple angle formulas here. It's just to be a single angle within it. So how do we go from here to here? We have, and they're kind of hard to see here, our where are they? Here's our double angle formulas and our sum and difference formulas. And in fact, we're going to need to use our sum and difference formulas. These are essentially our compound angles. So what I'm going to do is I'm going to break up this. I'm going to break this cos 4x into 2x plus 2x. 2x plus 2x is going to give us essentially the idea of 4x. So that's fine. The idea is we've decomposed this 4x. Okay. So now that we've done that, I have two sum and differences of cos. Well, if you look here, that's this formula here. It's hard to see, but cos A plus B is cos A, cos B, and depending on your sign, is plus sine A plus sine B. Well, luckily, both of ours are the exact same here. So we can now change this identity to say cos 2x times cos 2x, and because it's addition, so the addition becomes important, plus sine 2x times sine 2x. Okay, well, these are exactly the same thing, right? Think of it like a bracket times a bracket, and they are identical. So essentially, we can write this as cos 2x squared. And whether you write these squared kind of down here, which tends to be the practice, then out like this. And the reason they put it down here is because what it'll start to look like, if I put it up here, it'll look like it's 2x squared. So I usually either put brackets around the entire thing, if I'm going to put the power of 2 out there. If I'm not going to put brackets around the whole thing, I put the power in here, so it's a little easier to differentiate between the angle and the actual entire formula being squared. And in this one, I'll show you the difference. We would say sine 2x. Still the exact same thing, okay? Oh, no wonder I'm slowing down. Give me 1 second. Battery's dying again. So minus the fact that this is cos and this is sine, this squared outside of the brackets and this squared in here are actually the exact same thing. But remember, what we're trying to do is put this in terms of cos x. Now, technically, cos squared x and sine squared x, you can kind of almost equal 1, except that in ours here, we have a 2x instead of the x. That's the Pythagorean identity over here. So what we're going to use is actually one of our Pythagorean identities, this one here, sine squared theta plus cos squared theta equals 1. We're going to change this sine squared, call this theta here, into this formula so that we can rearrange it in terms of cos. So I'll write the formula down here and how we rearrange it. Think of it like sine squared theta plus cos squared theta equals 1. Well, we want to rearrange it in terms of cos, so we're going to say sine squared theta is equal to 1 subtract cos squared theta. Theta in this case is the 2x. Okay, so we're going to replace all of this with this idea here. I'm going to rewrite this one in terms of cos squared 2x now. Okay, so now we're going to replace this with, and I'm just going to, is it 1 minus cos? It is 1 minus cos. So we're going to have 1 minus cos squared 2x here. And we have our cos squared 2x. What did I do? This is good. I caught an error. So if I was to keep going this way, these things would eliminate, and this would equal 1, which doesn't make sense because of what we had here. The rule actually should be, if this is positive, then this is a negative. So I made a small error here. So that's going to change things quite a bit. This is a negative, which means this is a negative. Hopefully you kind of caught that as you're going through. So what that means now is this technically has a negative in front of it. Yeah, so when we multiply or distribute that negative inwards, okay, the 1 becomes subtraction, and the cos squared x 2x is positive, so we say plus cos squared 2x, and the 1 now becomes negative. So I just kind of rearranged their order, just so we can see that these two are the exact same thing. So now we get 2 cos squared 2x minus 1. Wonderful, except for the fact that we still have a double angle here. Okay, so we broke the 4 into 2, So now we break the 2 in, and I can go through this whole same process again with the inside one, but if we can kind of jump from here, and we can know that our angle formulas, here's our double angle formula in terms of cos, here it is. We can just jump from cos 2 theta to that instead, so we kind of went through the proof. So now let's do just this part here. The 2 will still stay on the outside. We know that cos squared 2 theta is equal to 2 times cos squared x minus 1. Okay, so that was the brackets part. We replaced, and then we have squared, because technically this here, so think of it like I took the squared out, I put it over here instead, because that would have been our double angle, our cos 2 theta. I put the square out here, so this part is still squared here, and then we subtract 1.
Did that say why it's squared here?
Okay, so because this was squared here, remember in our formula, that's a good question, I should have pointed that out. Here, there's no squared over our cos, okay? So this is where sometimes taking it from here and putting it on the outside makes more sense. So I've taken it out of here and put it to the outside now. So when I do that, my double angle, cos 2x, becomes 2 cos squared x minus 1. And then the squared is still here because that was only replacing this part here. Does that make sense now? Yeah, I should have specified that. So now this inside part is squared, so we can kind of use like a distributive property to deal with it. So we have 2, and this is 2 cos squared x minus 1 times 2 cos squared x minus 1, and then minus 1. So we can use our distributive property. We end up with 2 cos squared x times 2 cos squared x. That's going to give us 4. What's the easiest way to kind of write this in? 4 cos x4. I think that would be it. Minus 2 cos squared x minus 2 cos squared x, and then plus 1, and then we have our subtraction out here. We then have to distribute our 2 to every single term, and technically we can put those two terms together. Yeah, so that would be minus 4, imagine. So now it's 8 cos 4 power 4x. This was minus 4 if I put them together. Yeah, so minus 8 cos squared x plus 2 minus 1, and the 2 and the 1 just become 8 cos 4x minus 8 cos squared x plus 1 is your final answer. So lots there. We kind of went through a proof, and then you could have done the proof again, but we just skipped to a fast part, and then we had to distribute all of our terms in that whole process.